So today we have learned about similar polygons and some shortcuts that can be used for triangles. So we've already discussed in previous lessons that two polygons are similar if they're the same shape but different sizes. And the actual definition, though, that we're using is that the corresponding angle measurements are equal and the corresponding side lengths are proportional. So when it comes to triangles, we've learned some shortcuts that we can use with similarity, but we have to understand that these shortcuts do not work for other polygons. So if I have more than 3 sides, I cannot apply these shortcuts. So one shortcut that we learned is side-side-side similarity. So if the corresponding sides of two triangles are proportional, then the triangles are similar. And so the abbreviation would be side-side-side with the similarity symbol. So it looks like the congruent symbol, but you don't have the equal sign there anymore. So another way of saying this is two triangles are always going to be similar if all 3 pairs of corresponding side lengths are proportional, and I don't have to have any information whatsoever about the angles. Just the 3 side lengths by themselves is enough to know. So in this example, you can see that the scale factor is 2. So just because of that fact, these triangles have to be similar. So we've practiced making some similarity statements. So if I call the first triangle ABC, then I would put ABC, triangle ABC rather, is similar to triangle DEF, where I started at this angle and then went to angle B and then angle C. And remember, I've told you to make sure that you're showing the work to show that the side lengths are proportional. So you would need to show that 10 divided by 5, 16 divided by 8, and 20 divided by 10 all equal 2. A second similarity shortcut for triangles is angle-angle similarity. So if two triangles have their corresponding angles equal, then the triangles are similar. And the abbreviation is just AA and then the similar symbol. So notice we don't need all 3 angles, we really only need 2 angles. So 2 triangles are always going to be similar if 2 pairs of corresponding angles are equal. You don't need the last angle or any information about the sides. So if all I knew was that these 2 pairs of corresponding angles were the same, that's enough to know that the triangles are similar. And we've already talked about if 2 of the corresponding angles are the same, the third angle would have to be the same, but I don't really have to find that information out. So for the example here, if I start with this unmarked angle, it started angle G, and then I go to angle O and then angle T, I would have to name the second triangle the same way. So I would start with F, and then go to U, which is the 97-degree angle, and then go to angle N. And I would know these triangles are similar by angle-angle similarity. The third shortcut that works for triangle similarity is side angle side. So if 2 triangles have 2 pairs of corresponding sides that are proportional and the included angles are equal measure, then the triangles are similar. So remember, it's important to note that that angle that I know is between the 2 sides that I know are proportional. And so another way of saying that is 2 triangles are always similar if 2 pairs of corresponding sides are proportional and the angles between those sides are congruent. You don't need to know the third side length or the other measures. So for this example, if I call the first triangle ABC, so ABC, then I would have to name the second triangle the same way, so DEF. And they are similar by side angle side similarity. So then example 1 asks you to draw an example showing that just because 2 quadrilaterals have the same side lengths, it doesn't make them similar. So it's just showing you that although our shortcuts work for triangles, they don't work for more than 3 sides. So I could have a square where I have all 4 sides are the same length and all my angles are 90 degrees, and I could also have a rhombus. So my sides are all still the same, but this angle is 85 instead of 90. So these 2 quadrilaterals would not be similar. So then on example 2, it gives you different pairs of polygons and asks you whether or not they're similar. So on A, you've got 2 triangles, and the only information you have is the side length. So if you check the scale factors for all 3 pairs of corresponding sides, they all equal 2. And if you'd like to write it this way instead of writing 3 separate fractions that all equal 2, you're welcome to do that. And so these two triangles would be similar just by side, side, side similarity. And again, I don't need any angle information. So just because the side lengths are proportional, that's enough for me to know the triangles are similar. On B, I have two corresponding angles that are the same, so those triangles would be similar by angle-angle similarity. So again, there are three shortcuts that work for similarity for triangles. So angle-angle, side, 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 and side angle side. So I want you to pause the video and try C through F and see if you can determine whether or not the polygons are similar, congruent, neither, or is there not enough information. So on part C, the triangles are not similar because the corresponding side lengths are not proportional. So when you try to check the scale factor for one pair of sides, so to go from 20 to 10, the scale factor, or rather to go from 10 to 20, the scale factor is 2. But to go from 5 to 15, the scale factor is 3. So you don't have the same proportions for the sides. So not similar because corresponding side lengths are not proportional. And then on D, you don't have enough information. Side, side, side is only for triangles. So you can't tell whether or not these are similar because maybe this angle is 90 degrees and this is 91 degrees and you really can't tell because we can't go off of looks and we don't have the measurements given. And then on E, these would be congruent by side angle side. So I have two sides and the included angle that are congruent to each other. And then F, those two triangles would be similar by side angle side similarity. So you can see that the scale factor from the smaller triangle to the larger triangle is the same. It's 3. And then you have this included angle that's the same. So these are similar by side angle side similarity.